All right, shh. FSC, I'll go over any particular question that you still have issue with. Some people still have question about. I'm kind of gonna speed around certain questions because those are things that are important. So some people says, can you explain number 10 again? Sure. Square root of x times x minus 1. Is that right? Yeah. Okay, so what I do is what Chris did on What's Up is actually good, but it's just not a very visual thing to show you. So what happened is I will do a number line test, and that's why I say number line test is very important. 0 and then 1. And I'm gonna write down the factor here, x minus 1. The whole thing is I'm trying to have these two things multiply each other. When you have two things multiply each other, they can possibly get here. I only care about the sign because the square root of a negative number. So square root of negative number is I, and you don't want to get I because I is not able to graph. So you want a square root of positive value. So basically, you want an x and x minus 1 greater equal to 0, and also equal to 0 because you can square root 0. And you can solve for this, x equal to 0, x minus 1 equal to 0, x equal to 1. And that's how you find those critical points. Now, what you're going to do is test the intervals. From negative infinity to infinity, you're going to test by plugging anything between negative infinity to 0. So what would be a good number to plug in? Let's just say negative 1. If I plug in negative 1 here, that's going to give you a negative number. If I plug in this, it's going to be negative 2. So it's negative times negative is equal to positive. Any questions? If I plug in 0.5 into x, that's going to be positive. 0.5 minus 1, it's going to give you negative. That's going to give you a negative. That's why I say the first test, that number line test question, is very important. A situation like this. There's a whole chapter of the thing that you have to deal with number line tests. Sometimes you might have another factor, x plus 2. Then you have to write down x plus 2. And you have to do like plus, minus, plus, something like that on the top. You have to sum up all the signs. So it depends the situation. So this is positive, positive, positive. So your answer is you're looking for the positive region because you want to square root positive value. So it'll be negative infinity to 0 in a bracket, infinity, union, bracket, 1 to infinity. And that's it. So that's just a really easy understanding for this. Also, another thing I would like to share is the squeeze theorem. Also the one absolute value. I like the one absolute value. So limit x approach to 1/2 negative, right? It was 2x minus 1, I believe, and absolute value 2x to the q minus what? Minus x squared. In this case, I'm gonna factor out x squared. Why I factor out x squared? If you factor out x, it's not good, but factor out x squared is fine because x squared is always positive. So it's 2x minus 1, and this is an x squared absolute value 2x minus 1. So limit as x approach 1/2 to the negative. Now this is absolute value here. Now you can factor out absolute value, but long as it is x squared because absolute value of x squared is also positive. Okay, so that is fine. The problem is the sign issue that you're gonna have issue with. So now, if I'm going from the negative side, so that means I'm gonna use a negative version of absolute value. So it'll be limits x approach to 1/2 negative version. So 2x minus 1, and that's going to give you a negative version of 2x minus 1 times x squared. Does that make sense? And now those two will cancel out. That's equal to negative 1 over x squared when limits x approach to 1/2 on the negative. So that's going to be negative 1 over half squared. So it's negative 4, and the answer is negative 4 in this particular case. So yes, you can factor out x squared, but this one is you have to decide using negative route because you're using negative side of it. Okay, that's another thing. Some people did like that one. Make sure it's a negative 1 over 4, negative 1/2 at the end. So somebody did a work over there. It's really, really nicely done. It's combined fraction, conjugate, and all that. Some people figure that out. If you don't know how to figure out how to check your answer, use Desmos. Desmos is going to be one of the key that you can check things on graphically. That way you can understand two things at once. So math way might not be a good way, even though some people does use math way properly. So um, so not entirely is bad choice, but is using on different situations. I think for computation is very good because we can check an answer to math way. Um, so that's that. And the squeeze theorem. Squeeze theorem says limit x approach to infinity of 1 over x sine of 1 over x. Do you guys remember that? Now remember, this is obvious. It doesn't matter what value you plug in. It's going to be between -1 and 1. Right? And then I can multiply this by 1 over x. So -1 over x less than 1 over x sine of 1 over x less than 1 over x. Now, obviously, you want to reach limit x approach infinity. So limits as x approach infinity, -1 over x. I don't know who was it yesterday, point out 1 over infinity is 0. I think that's Ethan, right? Okay. Ethan, thank you for looking that up. That's very awesome. Ethan and Chris has actually helped a lot with everybody yesterday. And that's what I like to see. Those are really great positive feedback loops. Now, how do I really explain that understandable way? So let's just say x is going to get larger, right? So let's just say think about 1 over 10. And even if it's negative, it doesn't matter. 0.1 negative. -1 over 100 is going to be -0.01. -1 over 1,000 is -0.001. So the value gets smaller and smaller and smaller and more close to 0. So therefore, this is equal to 0 eventually. We're going to need to know that later. So it's good that I put those questions here. Limit x approach infinity of 1 over x. Same thing, but just positive 0.1, positive 0.01, positive 0.001. So this still going to 0. So therefore, this one has to be what? It's also equal to 0. Now, with that being said, let's look at a graph. The graph of this, sorry, this one is and this is 1 over x, right? And this is going to be 1 over x. And this is -1 over x. And we're going to do it here. Now, the things I'm not looking towards 0. A lot of people try to look to the 0, either as positive infinity to negative infinity. Oscillations does not exist. Here's the thing. I'm trying to look at a limit x approach infinity. So you're looking on this side. Do you see what I'm saying? It's squeezed into between the red line and the blue line. The black line is right in the center. And the red line and the blue line will eventually squeeze this black line into 0. Because the red line is going to go to 0, the blue line is equal to 0, and that eventually equal to 0. Does that make sense? Now, how about the other case? Now, what if I just name another case? Let's say x squared sine of 1 over x. When limits x approach 0. Now, some students decided to say, well, it seems like all the squeeze theorems are always equal to 0. Yes and no. In this case, they are equal to 0, but the way you approach 0 on this particular case is actually pretty cool. Because if you have x squared here, so I'm at do here. If you have x squared here, and it's gonna look like this, right? And obviously down the left side it's gonna be x squared, and on the right side it's gonna be x to the square. And this is a negative. Now what happened when it equal to 0? It actually doesn't show very clearly what happened, right? But if you zoom in, and this is, I think that's how you're supposed to appreciate math, to look at it graphically. I think if you look at the graph of this, you'll be amazed what happened in that little small spot. So look at here. It strictly oscillating between those boundaries. And if you make it look big, it looks really big here, but it's really, really tiny, small. So they are oscillating between those x, positive x squared and negative x squared. And it's truly amazing. I feel like this is the part like I think I enjoy teaching the math most. I personally doesn't like teach algebra 1, even though that's probably the really foundation of everything. And I teach outside like twice a week, algebra 1. And I do a very good job with those students. But this is the part that I think people can start appreciate what math is once you get to this level. When they go into like a system equation, solving for x, those are very simple. Just do the process. You should get an answer, completing the square, solving an equation. But this is not something that you actually gonna see every day. That they follow this so well and so disciplined about this. You know, it's just they did not in any point not pass the x squared. Okay, so that's the things that I want to tell you about. So with that being said, hopefully you understand a little bit better about squeeze theorem. Yes.
So would x ever be approaching something like 2? And in that case,
it can possibly be.
right. So if it was like -2 and then +2, what would the function equal?
Oh, you mean the n? I don't know. There's a lot of different cases, so I cannot say like ever happened like this. I always say there's a possibility that can happen because there is always a counterexample. I think there is always a situation that where the thing is true. I have seen a lot of squeeze theorem from UCF. In UCF, they kind of test like squeeze theorem a lot more than like College Board. College Board almost never tests. The last 10 you only show up once. It's on the free response, last question, last part. Only worth 1 point out of 108 points. And that's the only time I ever show up. No, a single time they ever talk about it. I talk about it is because this is where I appreciate math a lot more in this particular thing. Because I think it's beautiful. So and I think that's important. But the other question that it can have equal to different answers. Sometimes it can equal to e. But I'm not going to give you a situation. I'm going to give you a situation that you can work it out is equal to something. Okay. We're going to talk about trig limits. I already posted a homework on that, but sine of x over x, this is equal to 0. No, sorry, not equal to 0. I lied. It's equal to 1. The other one's equal to 0. Okay, so this is a 2 trig limit you had to memorize. The first trig limits that is actually derived from squeeze theorem. And I would usually go back to prove to you, but I don't have time because the explain of that part, you can watch it on YouTube channel. They will actually do a graph perspective. They will show you everything. I'm pretty sure they can do a much better job. Since I'm the worst teacher, so I should not explain to you that one. So, so the squeeze theorem can prove that sine of x over x is equal to 1. But you can also use graphing calculator to see what happened when they're equal to 0. Because sine of x and all over x. And if you look at it here, it's going to a 1. So it's between 0 to 2. And this is very close to 1. And if you do the other one, 1 minus cosine of x, parenthesis, divided by x. And this is going towards 0. Right? So we actually use decimal to show you that it's true. This 2 trig limit is true. And not only true, if you make them look like this, you can always use the property of limit to find out the evaluation. So today's homework, you got a few. So today we're going to start with the easy one, easy example. Let's say limits x approach to, I don't know, 0 of 10 of 4x over 7x, like this. And you say, okay, that's it. I didn't give this example earlier, so I feel like I want to give this example a little bit different. So, yep, I have this. Yes, let's ask one thing. Remember we talked about property limits. You can take constant outside the limits. So here's a question. You're gonna see this question is very dumb, but there's a lot of SAT questions they just ask you which part of the equation is a constant. Have you seen that before? Yeah, it was like really easy, but people still get it wrong. But I'm gonna tell you which part is constant. I think a lot of you guys will get it wrong here. So what is a constant in tan of 4x over 7 of x? No. Caden?
X approach 0.
No. That's not a constant. What is a constant in this expression of tangent 4x over 7x? Don't even look at a limit. Just look at it. Huh? X is not a constant. X is a variable. What? Tangent is a trig function. That's not also not a constant. 4 is not a constant because they are within the argument. What is it? Eli?
Tangent of 4.
Tangent of 4, definitely not a constant. Because the argument's right here, and that's what you need to see. Tangent of 4 is something else. So it's not tangent of 4 times x. It's tangent of 4x. Of 4x. So there's a parenthesis there. Good question. Anybody else?
Is it the division?
Could be. Can you elaborate more?
Because the division is constant, like they're always going to be dividing by themselves, even if the numbers change.
Kind of. Anybody else? Very easy question. In this expression, what is a constant? No, not the entire thing. One what?
I was just thinking like it's one of
No. So nobody can answer a simple questions here. Yes, Kaden? Thank you. I'm glad I'm not holding a breath, but if I holding breath, Kaden would have saved me this time. It's 1 over 7. So this, it can be outside. So it can be 1 over 7. And it's not 7 because Baden actually very, very close. He says is 7, but it's actually 1 over 7. So I can take the 7 outside, right? So I gotta make sine x over x happen. Not only that, make sure it's sine x over x when limits x approach 0, this is equal to 1. But also with limit x approach 0, what if it's sine of 2x? That means the bottom has to be 2x in order to equal to 1. So they had to be exactly the same. Is that okay? So what I'm going to do is I'm going to change it to tangent of 4x because that's how you convert. This is going to be sine of 4x over cosine of 4x times 1 over x, 1 over 7. Does that make sense? Now, normally, like, I told people, like, those of you guys have my my pre-calc class. Actually, I convinced Ollie and Kench to start from 4th grade. So last year, everybody started 4th grade from adding fraction, multiply fraction, dividing fraction. And I convinced them to do that. This year, I did the exact same thing. So when I told students I'm going to start with fractions, and they all laugh at me. All my 7th period, 33 kids, everybody laugh at me. But it's so important though, because 2 over 3 times 4 over 5, I can actually, this is times each other, right? If it's times each other, I can switch places, right? 2 times 4, 5 times 3, right? I can switch this place because they are times. They can switch places, right? Does that make sense? Result's still going to be the same. Yeah, I'm sorry. Yeah, no, that's a really bad. Thank you. So I can switch this 5 and 3. I can even switch 2 and 4 if I really wanted to. That's associative property. I think, wait, is associative or commutative? I don't remember. Associative? Okay. Benicia can correct me. I don't know those property. So then I can say, well, that's gonna be 1 over 7 times limits as x approach 0 of sine of 4x. Now I'm gonna move this x toward here. I'm gonna replace that and times 1 over cosine of 4x. Does that make sense? I switch them. If I switch them, then it's gonna be sine of 4x over x. Now the only thing I'm missing is this need to be a 4 here, right? If it's 4, then it says that's one of the trig limits I know. So when you do something magical, I love this number. The number is 1. Why do I multiply by 1? But not any other type of 1. I want to be 4 over 4. Not just multiply by 4. I need to multiply by 4 over 4. Because if I multiply by 4, I change the fraction. I need to multiply by 4 over 4 so I can make sure that this can replace in right here. So then therefore it's going to be 1, 7. Limits as x approaches 0 of sine of 4x over 4x times 1 over cosine of 4x times 4. Because I only take that one denominator 4 inside to qualify that trig limits. So now I can also take out a 4 because that's a constant now. So it'll be 4 over 7. Limit x approaches 0 of sine of 4x over 4x times 1 over cosine of 4x. So what's the first rule on limit? You should plug in, right? Well, this one we know. What is this one? Sine of 4x over 4x is 1, right? According to what we know, this part is 1. But how about this part? What's cosine of 4x when x equal to 0?
It's also 1.
Why is 1?
It's 1 over 1.
It's 1 over cosine of 0. So 1 over cosine of 0. Cosine of 0 is on your last test. I purposely put there. Why did I put cosine of 0? Because everybody does 0. But cosine of 0 is actually 1. So it'll be 1 times 1. And this is times by 4 over 7. So the answer is 4 over 7. And that's the answer for that particular questions. Yes, sure.
How was sine 4x?
Because that's one of the trig limits. Because sine of x over x. Now remember, this has to be exactly the same.
Yeah.
That's okay. That's a great question. Does that make sense? Now, you got a whole trig worksheet today. And I should see a lot of people at tutoring. Yesterday, I want to talk about tutoring. Because tutoring, I have down to 6 people from before it's 80 people. Now, before I can smell the sweat when I come into the room. Which is, in a way, it's good. In a way, it's bad. But this time, I need to see more people at tutoring. So, you're going to have this trig worksheet to work through. A lot of them are identity. A lot of them how you split things. And how do you rearrange things. So you got to make math happen here, but you cannot break the math rule. What I mean by breaking the math rule is people does this shit a lot. They say limits as x approach 0 of sine of 4x over 9x, something like this. And they say, oh yeah, I can cancel out this x. No, you cannot. You cannot cancel out the x. That's bad. And sine can just disappear. So my answer is 4 over 9. Yes, I got an answer. Please don't do this because that is not math. Okay, please don't do this. So, do the proper thing. Make sure you're using multiplications and stuff like that. I want you to start trying the questions. Here's a question we want you to start. And the nice thing, the second page has an answer, so you can know if you did it right or wrong. So I also provide an answer. Now, second part has a lot of trig identity. So you have to worry about trig identity as well, knowing how to simplify fractions. Sure.
Wait, is this a homework?
It's a home. There's a homework. So when I see sine squared 3x, I think about sine of 3x times sine of 3x. That's the things I think about. I kind of like, I don't know, you guys like Naruto when you grow up? It's kind of like shadow clone. You can like split. What is it? I don't know how do people do it. How to do Naruto shadow clone? Is this way? This way?
Yeah.
Is this way? Are you sure?
Yeah.
My favorite character is not Naruto. Rock Lee. I like Rock Lee. And also the smart one who control the shadows.
Super Mario?
Yeah.
Yeah, he's
That's my two favorite characters. I don't like Sasuke. I don't like Naruto. Naruto is an idiot. Jesus is a Naruto fan.
No, not really.
No.
More of a One Piece fan.
One Piece?
Yeah.
That thing never finished.
It's so good. So good. It's so worth it. Trust me. It's only 1,000 episodes. Quarter of a century old.
You can take a picture of you if you want.
Only 1,000 episodes.
And there's an answer on second page.
Is there a particular reason as to why when you multiply it by 4, at one stage of the tier, but one goes all the way up?
Because 4 can be anywhere.
Just
Yeah, I can switch 4 times here. 4 times.
yeah, just because of that.
Yeah, they have denominator. It can go anywhere. It will go to where it fits, right?
Right.
Well, Bennett, we're in that.
I didn't times 1 over x. I moved this 1 over x. Yeah, because this is 10 of 4x times 1 over x, right? Does that make sense? So I just do 1 over this, and 10 of 4x I change to sine of x.
Okay.
I'm gonna spend time doing another question. I think most of my BC students have a problem with this one. Sine square of 4x over 5x squared, like this one, and limit x approach 0. So they have a question about this one because they mess up. Most of BC students mess up. X approach 0, I'm gonna write down sine of 4x times sine of 4x. Is that okay? And that's also x times x, right? Times 1/5. Do you see that? If I multiply everything, would I get sine square 4x over 5x squared? Yes. So I can take out 1/5 outside because I don't like that. So 1/5 here. So what do I need on here? What do I need here? 4 and 4, right?
Yeah.
So what's 4 times 4? 16. So I multiply 16 over 16. So this is gonna come out here to become 4 and 4 instead. So it'll be limits x approach 0, sine of 4x over x times sine of 4x over 4x times 16 and 1 over 5. So this is gonna go to 1. This is gonna go to 1. So the answer is 16 over 5.
I have a question.
Sure. Yep. Yeah, but you need an x, right? You need to multiply this by 5. But you want a 5x here. You don't want a 5 here. You want a 5. No, sine of 5x over 5x is 1. Not sine of 5x over 5.
Oh, so just 5?